Welcome to section 1.6, day 2, operation with functions and function composition. Today's objectives are to find compositions of functions. So our key concept today is composition of functions. The composition of functions f with function g is defined as f of g of x, that circle in between, or can be read as or written as f parentheses g of x, end of parentheses. The domain includes all x values in the domain of g that map to g of x values. And it shows you the picture on the right. So what we do is we apply the g function first, if we have f of g of x, and we take those values we get back and plug them into f. Like I said, you should have done this before. This will hopefully be a review. So we're given g of x equals x minus 4, and f of x equals x squared plus 1, and we want to find f of g of x. So what we end up doing for this first one is we're going to take the g function and plug it in for x in our f of x function. So we have f of x equals x squared plus 1. The f of g of x is x minus 4 squared plus 1. And then we expand and simplify. X squared minus 8x plus 16 plus 1. And we get x squared minus 8x plus 17. This is our composition of functions. And if you look at these, if you're asked for the domain, if you look at both of these, there is no restrictions on our domain. So our domain would be all reals, or you do negative infinity to infinity with your interval notation. The bottom one, we have g of f of x. We're just going to reverse it. We're going to plug f of x function into our g of x function. So our x becomes x squared plus 1 minus 4. And we simplify, and we get x squared minus 3. This is our g of f of x. Again, there's no restrictions. We are still using our same two functions, but now we're going to find f of g of 2. There's a couple of different ways of doing this. You can plug, since g is going to go into f, you could actually plug the 2 into the g function first, get your value, plug that value into the f function. So let's do it that way first. We know that g of x, I should say, we know we have g of 2. If we plug 2 into the g function, we get 2 minus 4, which is negative 2. We can then plug negative 2 into f of x. And f of negative 2 is negative 2 squared plus 1, which is 5. So if you do this way is one of the ways to do it. But from before, we found that f of g of x, this is from the previous slide, we found this earlier is x squared minus 8x plus 17. So now if we do f of g of 2, we get 2 squared minus 8 times 2 plus 17. And we get 4 minus 16 plus 17, which is 5. So you can do this either way. You can plug the 2 into the g function and then get your answer and plug that into the f function. Or you can actually compose the two functions together first and then apply the 2 to your composite function. It is your call. You'll get the same answer either way. It's a personal preference usually how you do this. All right, so here we're going to find a composite function with a restricted domain. So we have the f of x is equal to 1 over x plus 1. We have g of x equals x squared minus 9. And we're going to do f of g of x. So what that means is we're going to plug the g function into the f function. We are going to take this and plug it in for this. When we do these, we always want to see if there's any restrictions on our domains before we even start. And since we're plugging g of x and f of x, is the restrictions for x squared minus 9? Well, there aren't any restrictions for that, so we can plug it in without problems. The first thing you look at is, are there any restrictions on the function we're going to plug in the other one? There are no restrictions on g of x, so we can plug it in. So then we have f of g of x. We're going to take and plug this in, so we have 1 over x squared minus 9 plus 1. And when we do this, we get 1 over x squared minus 8. So this is my composite function. The f of g of x is 1 over x squared minus 8. Well, now we did this composition, we do have a restriction in our domain here because we're dividing by something that has a variable in the denominator. We have x squared minus 8. So when we do this, x squared minus 8 cannot go to 0. So we will solve this and see what makes our domain go to 0. So we will solve this to see what makes our denominator go to 0. So x squared equals 8. We take the square root of both sides, and you get x cannot equal plus or minus the square root of 8. And we have plus or minus the square root of 8, so we need to simplify the radical. Don't forget to do that. This is 2 square root 2. Our domain is restricted. We can't be positive or negative 2 square roots of 2. So we have our domain. Our domain goes from negative infinity to negative 2 square roots of 2. Union, negative 2 square roots of 2. To positive 2 square roots of 2. Union, 2 square roots of 2 to infinity. This is my domain. If you had to do it in set builder, it'd be x such that x cannot be equal to negative 2 square roots of 2. X cannot be 2 square roots of 2. X an element of the reals. This is in set builder notation. All right, so that is our restricted domain. Always check when you're done with your composition if there's anything that would make your denominator go to 0. Or if you would have a radical, but would make it so you can't take the square root or fourth root of something. For this one, we want to do find f of g of x. We have f of x is x squared minus 2. G of x equals the square root of x minus 3. So we're going to plug this in for x. But again, look at what your g function is first, your g of x. Is there something that makes a g of x not work? We need to look at that before we do anything else. Well, g of x, we have a radical, we have a square root symbol, so our x minus 3 has to be greater than or equal to 0. Otherwise, it won't work. So x has to be greater than or equal to 3. That is a restriction we have just for the g function. Now we're going to plug in the g function into the f function and see what else happens. So we're going to do the f of g of x. It's equal to the square root of x minus 3 plugged in for x all squared minus 2. When you square the square root, you get x minus 3 minus 2. This is x minus 5. So now we have the f of g of x is x minus 5. When you look at this function, it doesn't look like there's any restrictions at all, right? Because we have nothing in the denominator, we have no radicals left. It's just looks like a line function. But when we started, we were not allowed to do this. We had to have x greater than or equal to 3. If you would actually put this part in your calculator before you simplified it, you would see that your line has an ending point. It can't go past to the left of 3. Your graph would start at 3 and then go. If you actually graph it, you'll see that because there's a restriction. So for this one, my domain that I'm allowed to have, because the g function before we did anything is restricted, is going to be from 3 to infinity. Like I said, if you graph it, you will see that. So always double check your restrictions on your function that you're plugging into the other one first. Here we check g of x to make sure it would work, because when you plug it into the f of x function, things can change. So you have to look for it before you plug things together. That is all for 1.6 day 2. Thank you for watching and have a nice day.